This is Daniel Coosbury, and in this section we're going to start talking about measurement and some really kind of practical things to do there. There's a lot of different ways of measuring things and a lot of different systems, and so we're going to have to get used to converting things and understanding the units that we're seeing. So we'll start out in this section just with length, and so what I've done is I have copied and pasted a part of a formula sheet that you're going to have at your disposal when you take the next quizzes and tests and whatnot that have to do with length. So there's a formula sheet online that has a bunch of different conversions, and this is just the piece that has to do with length. So I posted this on these slides so that you can kind of get comfortable looking at it and know this is what you're going to have at your disposal, and this is how I'm going to kind of show you how I would use this to do the problems, and you can kind of figure out what works for you. But anyway, we're going to start just kind of doing some conversions in the American system, and we're going to use the process called dimensional analysis, where we use these conversions and we turn them into what's called unit fractions. They're going to be fractions that have a unit in the denominator and a unit in the numerator, and we're going to use them just simply to convert. So I'll just give you an example. We're going to convert 30 feet to inches. And to do that, I'm going to multiply by a fraction, and the fraction is going to need to convert the feet to inches. And in order to do that, I need to put a unit down here in the denominator that'll cancel out the feet. I'm going to put a feet down here, and I'm going to put my desired unit up here, the inches. So when I do the multiplication, the feet cancel, and then I now have inches. So from this point, I'm going to look over here into my little blurb and see where do I have a conversion from feet to inches. Maybe I don't. Okay, well that's one that most of us know. Okay, there's one up here. So I guess that's not useful or at your disposal. But anyway, there's this is probably should be common knowledge that 12 inches is equal to 1 foot. So that might just be something you need to memorize. So with a conversion like this, I can put these numbers into this unit fraction here. 12 inches is equal to 1 foot, and then I'll do the multiplication, and it'll give me the right answer. So when I do the multiplication, the feet cancel, and I have 30 times 12 divided by 1, or simply 30 times 12, and that gives me 360 inches. So that's how that sort of dimensional analysis works. So I can do the same thing here, and here I do have something here in the formula sheet that's going to help me. I'm doing 12,000 feet to miles. I want to do a unit fraction that has feet down here, so the feet cancel, and miles up here. And then I'll use this thing right here that tells me for every mile I have 5,280 feet. So for every 1 mile, I have 5,280 feet. So I know I've set up this unit fraction now because I've used this conversion here, and I also have feet in the denominator so that when I multiply it cancels. So I multiply 12,000 times 1, which is 12,000, divided by 5,280. So I'm going to do 12,000 divided by 5,280. And when I do that, I get 2.27. That's going to be miles, because that's the only unit left. The feet canceled and the miles kind of sticks here. All right, let's do this last one. I have to pull this over here. We want to do 10 inches to yards, and I guess those conversions are not in here. So it should be well known then that there's 12 inches is equal to 1 foot, and 1 foot is equal to, nope, hold on, let me say that again. 3 feet is equal to 1 yard. So there's, I mean, that just, if you don't know that, that might just be something you need to study. But I can do the same kind of dimensional analysis here. I'll start with 10 inches, and then I want to multiply by a unit fraction that goes from inches to yards. Well, I don't have something here in my brain that converts from inches to yard, but I can convert inches to feet, and I can convert feet to yards. So this process is actually going to allow me to do the conversion twice. I can just make 2 unit fractions. I can make an inches to feet one first, where I want inches to be in the denominator so that they cancel out. And then I have 12 inches and 1 foot. And then I'll do another multiplication that'll go from feet to yards. So let me make another unit fraction. Now I want feet in the denominator, so that cancels out, and yards to be in the numerator. So what I've got is inches and inches are going to cancel, feet and feet are going to cancel. I'll be left with yards, which is what I want in. And using my conversion that I had in my head, 3 feet is equal to 1 yard. So this says if I take 10, I multiply it by 1 divided by 12. So 10 divided by 12, and I multiply it by 1 and divide by 3. So this is really equal to 10 divided by 12. And that whole thing is going to be divided by 3. It's all going to be yards. So I would do that kind of just like that in the calculator. 10 divided by 12 divided by 3 is equal to 0.27 yards. Which is not that different than this number up here. But anyway, so with this dimensional analysis method, you're able to convert from one thing using several of these conversions, making several unit fractions. Okay, there's another system that we're going to have to learn to use, and this one's actually nicer to work within itself, the metric system, because the metric system has these prefixes, and the prefixes just kind of change your unit by a factor of 10. So if you start out with a meter for length, a decameter is going to be 10 meters, and then hectometers 100 meters, kilometers 1,000 meters, and then you go the other way, these will be 1/10, 1/100, and 1/1000. It's just changing by a factor of 10. And so the conversion process is actually pretty nice, and I learned this mnemonic that I found is pretty helpful. If you're trying to go from any of, so here's what I've done. I put these things kind of in a row from like biggest to smallest, and if you try to go from one of these bigger units to one of the smaller units, it amounts to simply multiplying by some kind of factor of 10 or to some power maybe, or like 100 or 1,000. And multiplying by 10, all that really does is it moves the decimal. So like if you want to go from kilometers to hectometers, you move the decimal one place. If you want to go from kilometers to decameters, you'd move the decimal 2 places to the right, and so on. So there's kind of this idea here. If you want to go from meters to decimeters, you'd move it 1 to the right, because you're just multiplying by 10. And so it works out really well, and I'll kind of show you this in action. But what also happens, though, is when you want to go the other way, go from one of these smaller units to one of the bigger units, you're going to be dividing by some power of 10, so 10 or 100 or something. And that would amount to just moving the decimal 1 place to the left, or a few places to the left. So when you divide by a power of 10, you move the decimal to the left. And so having these prefixes kind of written out like this can actually really help do these problems. So let me show you on this next slide. I have the same thing up here. I want to convert 125.9 meters to kilometers. So using that mnemonic, I'm going to start at meters, and I'm going to go to kilometers. So I'm going to go 1, 2, 3 places to the left, if I've written this in order and all that. So that means I'm going to end up dividing by 1,000, which moves the decimal 1, 2, 3 places to the left. So from here, I'm going 1, 2, 3 places to the left. There's that little squiggle, which means this is equal to 0.1259 kilometers. Now again, that's the same thing as me dividing by 1,000, which again, you would know that's moving the decimal 3 places to the left. But what's nice about having these written out is I don't have to worry so much about which power of 10 do I multiply by. I can just think how many times I need to move it left or right. So let's do this again. I'm converting 35 meters to centimeters. I'm starting here and I'm going to centimeters. That's going to take my decimal here and move it 2 to the right to give me 3,500 centimeters. That's really nice. That doesn't require a lot of like hard thought. It's the mnemonic really kind of helps you do these problems quickly and efficiently. So here I'm going from millimeters to hectometers. So I'm starting here. I'm going 1, 2, 3, 4, 5 to the left. So if I do that, go 1, 2, 3, 4, 5. That's squiggle. That's going to leave me with 0.01042 hectometers. So my decimal started here, and I moved it 1, 2, 3, 4, 5 to right there. I just like to put this little placeholder 0 there, so in case you can't see the dot. The dot's right there, but you know it's there because there's a placeholder. Anyway, let's do just one more. I think you might see my point, but let's go from decameters to decimeters. So starting here, we're going to move the decimal 2 to the right, which means this would be equal to 14 decimeters. Oops, I didn't do the abbreviation right. So 1, 2. That's how that would work. So converting within the metric system is really nice and really straightforward, which is why we like the metric system. Now, where things get a little wonky is we now have two systems of measurement, and some people use one and some people use the other, and we're going to need to know how to use both. So that's where most of these formulas really come into play. I guess these down here, is they're going to help us convert from the American system to the metric system, and we're just going to use dimensional analysis still to figure this one out. So I'm going to go ahead and start, because now I've got all these conversions here. I'm going to start with 24 inches, and I want to convert it to centimeters. And I know that when I do dimensional analysis, I need inches to be down here so that they cancel. So centimeters goes here, and now I'll go over here and find, oh, okay, 1 inch is equal to 2.54 centimeters. So I'll use this conversion the same way I used the last ones. 2.54 centimeters is equal to 1 inch. So if I do the multiplication, the inches cancel, and I have 24 times 2.54, which gives me 60.96 centimeters. That's kind of nice. So that, honestly, with these conversions, that's not any harder than some of the problems we already did within the American system. Okay, but we can do a few more. So let's do 204 miles to kilometers, 204 miles. And I want to multiply by something that'll give me miles down here and kilometers up here, which I think I have that. Do I have that? Yeah, I have that right here. 1 mile is equal to 1.6 kilometers. So 1.6 kilometers is equal to 1 mile. So that's multiplication too. The miles cancel out. 204 times 1.6 is equal to 326.4 kilometers. You probably observed this by now, but every time we do one of these problems with a dimensional analysis, we're either multiplying by these numbers or we're dividing by these numbers. And it all depends on how it comes out when you put the appropriate unit down here. So again, I'm putting inches down here so it cancels, putting miles down here so it cancels. You may see when that happens there, the one ends up on top or the one ends up on the bottom. It all depends on the problem and what you're trying to do. Let's do this last one. So 30,124 millimeters, and I want to go to inches. And I bet I don't have something on this thing that goes from millimeters to inches. Nope. I have inches to centimeters. So that's kind of nice. But I don't have inches to millimeters. So let's convert this to centimeters first. And I guess I can do that with dimensional analysis. We haven't actually done that, but it's doable. If I want to put millimeters down here and centimeters up here, I know that 1 centimeter is equal to 10 millimeters. You divide by 10 to get to centimeters. And then I'll do this again. Now that I have centimeters, I want to put centimeters down here and inches up here, and I can put that 1 and the 2.54 here from my formula sheet, which is right here. Okay, so I'm doing kind of like that long problem I did in the first example. So I'm going to take this number, I'm going to divide it by 10, and then I'm going to divide it by 2.54 to get my answer. And notice the millimeters cancel, so that's good. The centimeters cancel, and I'm left with inches. So I'm going to divide it by 10, and then I'm going to divide it by 2.54, and strangely enough, I end up with nope, I did something wrong. Let me try that again. That looks better. I end up with 1,185.98. I don't know, just round it to 2. And that's going to be in inches. So that's doable. So really the takeaway is dimensional analysis works with all of these conversions. So it's kind of on you to get used to doing not only that, but also get used to knowing what's on the formula sheet and what's not. So things like the 12 inches equals 1 feet is not on here, but also the millimeters to inches is not on here, but we do have it in centimeters to inches, so we might have to do a multi-step conversion, but we can do that. Let's do a word problem just to kind of, get our heads around how we would use this in context. And so I just picked a silly example where we have a baseball diamond that measures 27 meters along each side. And if a batter scores 2 home runs, how many kilometers did the batter run? So this is not going to be too challenging at the end of the day, but we need to we want to imagine a baseball diamond, and it's 27 meters along each side. So there's that, 27 meters and 27 meters. And we just want to imagine that a baseball player hits 2 home runs. So in 1 home run, he's going to run all the way around the diamond. In another home run, he's going to run all the way around the diamond again. And we just want to know how many kilometers he ran. So let's start by finding out how many meters he ran, which is not going to be a hard thing. Because one of these sides is equal to 27 meters. 1 home run is going to give you 4 times around those sides. 1, 2, 3, 4. Another home run is going to give you another 4 around there. So we'll just multiply it times 4 and multiply it times 2 just to get the actual distance you're going in meters. So 2 times 4 times 27, that gives me 216 meters, which is not the answer to the question, but it's almost the answer. So the question is, how many kilometers did the batter run? Well, let's see. If I use my mnemonic, I got kilometers, I got hectometers, and I got decameters, and I got meters. If I want to go from meters to kilometers, I'm going 1, 2, 3 to the left. So I'm moving my decimal 1, 2, 3 to the left, and my answer to this question is 0.216 kilometers. So not a terribly hard thing to figure out, but you might see some word problems where you kind of got to work within your context, but then answer the question by converting to a context that's more understandable maybe. So yeah, that's it.